Hi, so I'm actually moving so that this light isn't directly behind my head, which probably will be anyway, but let's just kind of sit over here. So I am looking at question D of question 1 of the NCEA Level 2 2019 paper. When I first looked at it, and I was just trying to give questions to my class, and we've only done differentiation. I thought it was an integration question because it was asking for the quadratic function, but actually on looking at it, it's also a derivative question. So I am just going to do that now as part of this group of answers that I am doing. So first of all, we need to just think about what I've been told and what I can do to solve this problem. So it says use calculus to find the quadratic function of x that has the following properties: a rate of increase or gradient of 7 when x is 0, a turning point when x is 1, and a value of negative 20 when x is 4. So basically I have some quadratic function, f of x, and I know then it's going to be ax squared plus bx plus c, because that is the general formula for a quadratic equation that you would have done from year 11 and hopefully in algebra and in graphs and just over and over again. So you've done that a lot of times. So I'm just going to start with that as something that I'm kind of remembering and see where we can go from there. Now, first of all, it tells me that my gradient is 7 when x is 0. So let's first of all think, well, I know the derivative of f of x will give me my gradient. So let's have a look at f dash x and see what that's going to look like. So I'm going to have 2ax plus b. Okay, and I know that it's 7 when x is 0. So at f dash 0, 2a0 plus b equals 7. I hope you kind of followed that. I just substituted the x is 0 in, and I know that my gradient is 7 when x is 0. So I know that f dash x of 0 is going to give me 7, which is great because I know that anything times 0 is 0. So that's cancelling that out, and I'm left with a nice little b equals 7. So now I'm sitting nicely with, I know that it's going to be ax squared plus 7x plus c. That's just a bit of extra information that I have. I know that I have a turning point when x is 1. Now, what do we know about turning points? I hope a little bell has gone off. I know that my derivative, x, so I've still got 2ax, I know it's plus 7 now, is equal to 0, and in this case, so that's for turning point, and I know that this turning point is when x is 7, so I'm going to substitute f of 1 when x is 1, so it'll be 2 times a times 1 plus 7 equals 0. I hope that all makes sense. So this will just be 2a equals negative 7. So a will equal negative 7 over 2. So I now know I've got negative 7 over 2 x squared plus 7x plus c. And the last information is actually just information about the original quadratic equation, just about f of x. So it has a value of negative 20 when x equals 4. So I know that f of 4, so I'm going into my original equation, so I know it's negative 7 over 2, 4 squared, plus 7 times 4 plus some c is equal to negative 20. I seem to have gone into my other line there a little bit. Just going to change that to negative 7 over 2. And that little bit was, where am I? Sorry, 7 plus some c. Okay? Just so it looks a little bit tidier. So I hope you're happy with that. We were told the value of the function is negative 20 when x is 4. So I've just substituted 4 in and let it equal negative 20, which is going to give me a nice c right in there. So, I am going to just have a little look at this. 4 squared is 16 divided by 2 is 8. So times 8 plus 7 fours are 28 plus c equals minus 20. We've got negative 7 times 8, which gives me negative 56 plus 28 plus c equals negative 20. So that's going to be c equals minus 20 plus 28, because this gives me negative 28. So c will be 8, which is nice and handy. So I have negative 7 over 2 x squared plus 7x plus 8. And that's my function there, QED. So what did we get? We got told it was a quadratic function, so I just set up an equation there. I was told that my rate of change, or my gradient of 7 when x is 0, so I just did the usual thing that I do, set up an equation and solved, and then substituted that 7 in, and every time I got more information I just needed to substitute a little bit more in. So just remember where you're at, remember what you know, and go, just go with it. Sometimes you need to go a little bit to find out what it wants you to do. So hopefully that was made sense, and I'll see you next time.